So let us discuss about the measure of dispersions. How to dispersions we have to be measured. The following measures of the dispersion are used to study the variation, the range, the coefficient of range, interquartile range and the quartile deviation, the mean deviation and the average deviation, and standard deviation. So let us see how can we find out the range. First of all, the range is the simplest of all measure of dispersion. It is defined as a difference between the largest and the smallest item of the distribution. So here what is given there, age of a sample of a 10 subject from a population of 169 subjects are x1 is equals to 42, then x2 equals to 28, x3 equals to 28, x4 equals to 61, x5 equals to 31, x6 equals to 23, x7 50, x8 34, x9 32, x10 37. The youngest subject in the sample is 23-year-old and the oldest is 61 years old. The range of is equals to XL minus XS, the largest and the smallest. So what we have got 61 minus 23 and the answer is of the range is 38. So if the mark received from this means if the age we have compared here the age. So the range is measure of absolute dispersion. It cannot be usefully employed to compare the variability of the two distribution expresses in the different units. Uh, Next, we are discussing about the characteristics or you can the characteristics of the range. So the simple and the most cured measure of the dispersion, it is not based on an observation unduly affected by the extreme value and fluctuation of sampling. The range may be increases with the size of the set of observation through it can be decreases. Gives an idea of the variability very quickly. So here what we have done is range if you want to find out the coefficient of the range. So the large minus small divided by large plus small. So the large minus small we got 38 and the large plus small we got the 84. So 38 divided by 84 so answer is 0.452. Actually the coefficient is coming every time coefficient answers is come less than the 1. If the 1 is comes it means it is completed. So that is why most probably its answers come less than 1. So here they are explaining the quartiles. How can quartiles? So already we have discussed in the mean about the quartile that the area of quartile is like that. Means here we have seen with the help of figure that the medium is equals to 50% of any scale. So less than medium equals to 25% area and less than after completing the median. So next area that is less than here. So 25% again, but we have to add it like that. So it is called as 75%. So Q1 equals to 25% and Q3 equals to 75. So likewise that we can divide the quartile. Here is the formulas of the quartile. Quartile 1 n1 plus 1 n plus 1 divided by 4 and 2 equals to n 2 into n plus 1 divided by 4. And if we want to find out the quartile 3, so 3 then n plus 1 multiply by 3 divided by 4. So we got the answer. So interquartile range, the difference between the third and the first, that is comes the interquartile. Semi-interquartile range equals to Q3 minus Q1 divided by the 2. So coefficient of the quartile deviation means Q3 minus Q1 divided by Q3 plus Q1. With the help of example, we will see this thing here. So interquartile range means the range in a cured measure because it take into account only two extreme values, that is the largest and the smallest. The effect of extreme values on range can be avoided if we use the measure of interquartile range. So interquartile range refers to the difference between the value of the two qualities. Some merits and demerits are given here of interquartile range. It is superior to the range of the measure of dispersion. A special utility of in measuring the variation in case of open end distribution, or one which can data may be ranked but measures quantitatively. Used in erratic or badly skewed distribution, the quadrille deviation is not affected by the presence of the extreme values. So they want to say that these are the things that interquartile, how can it was not affected by the different upper limits. They are just, we have to find out the quartile deviation with the help of q3 minus q1 upon 2, or coefficient of quartile deviation equals to q3 minus q1 and upon q3 plus q1. So we find out the coefficient there. And is a measurement of the relative standard in the Z scores for an observation, or standard score. It describes how far individual item in a distribution departs from the meaning of the distribution. So here we will discuss about the mean absolute deviation, MAD, or the, you can say, mean deviation. What is mean by range? Interquartile range and the quartile deviation suffer from the common defects, that is they are calculated by taking into the account only two values of a series, either the extreme value as the case of range, or the value of the quartiles as in the case of quartile deviation. Mean deviation is a series of arithmetic average of the deviation of various items formed in the measure of the central tendency. Mean mode median. Mean deviation is also known as the first moment of the dispersion. Mean deviation is based on all items of the series. Theoretically, mean deviation can be calculated by the taking deviation from any of the three average, but in actual practice you can say mean deviation is calculated either from mean or from the median. Mode is usually not considerable as it is a value of determine, and it gives the erroneous conclusion. So that is why people are not using the mode. They will use mean, and most after the mean, if they are not getting proper answer, then they will use the median also. But mode is not, most probably mode is not preferred by them. So while calculating deviation from the select village, the sign plus or minus of the deviation are ignored and all the deviation are taken as a positive. Here example is given. Find mean deviation and confinement of the after delivery in the following series. Number of days consignment or number of patients, confinement days, total days of the confinement of each group, x minus s, x and f. Absolute deviation of the mean is mean divided by the mean bar, sorry, x divided by the x minus by the mean, and we got the answer 1.6, 0.61, 1.6, 2.61 and 3.61. So After then, we have to multiply them and we got the answer 8.0 like that. So the mean days of the confinement is 137 divided by 18. So answer is 7.61. Mean deviation 31.98 divided by 8 equals to 1.48. Coefficient of mean deviation is 1.78 divided by 7.61. So we got the answer 0.3233. Now find the mean deviation of weightage and coefficient of mean deviation of the 470 infants born in the hospital in 1 year from the following table. So here the data is given to us in exclusive series with that. So simple to understand and easy the compute based on the observation. Mean deviation is less affected by the extreme items than the standard deviation. Greatest drawback is that the algebraic signs are ignored, not evident, and the further mathematical treatment is given there. So we have to find the positive square root of an average of squares for the deviation of the observation from the mean. This is also called the root mean square deviation. These are the formulas for the individual series and for the discrete series. For continuous grouped series with the class midpoint M1, if the midpoint is given, then M1, M2, M3 like that they have to do, and corresponding the frequency F1, F2, F3 like. And then we have to use the root square formula. So variance is the square of S dot S full stop D. Coefficient of variation is corresponding relative measures of dispersion. So infinite divided by 100 into 100. Standard deviation. What is mean by standard deviation?